running design storms for the POC submodel. You've already received a typical year submodel. You can use the same model for running design storms. There are just a few caveats, additional files that need to be updated to be able to run the design storm. So we'll discuss that today. Okay.
Right.
I'll talk louder. Is that better? Okay. First, I'll just talk about the model background. Then we'll discuss how we developed the ALCASAN model, mainly how we developed the flows going into the model. Then we'll go into how to actually run a design storm. And then I'll do a demonstration in both PC Swim and EPA Swim. So just to give you a little background on the ALCASAN models, it was originally created by ALCASAN. It contains the interceptor system, the ALCASAN existing regulators, and a skeletal network of the municipal trunk sewers. Those are mainly the larger sewers connecting directly into the ALCASAN interceptor. The model is calibrated based primarily on the regional flow monitoring plan from 2008, and that was supplemented with historical monitoring dating back to 1993. Non-synoptic monitors were also installed for 12 months at a time on the municipal trunk sewers, and these were calibrated. These were used to calibrate dry weather flows and wet weather flows. December 2020 updates to the model primarily consisted of hydraulic changes, so any pipe sizes that may have been off, or any projects that were implemented at that time were brought into the model, and that's the model that we. December 2020 existing emissions model is the model we're using and that we've delivered to the municipality so far. So Three Rivers Wet Weather received the system-wide existing conditions model. That's a December 2020 model from ALCASAN. That model is broken up into smaller submodels and distributed to municipalities, and that was done primarily to minimize simulation runtime. So instead of having this large model that took 2 to 3 days to run, you have these much smaller models that take minutes to run. And this allowed more efficient and cost-effective alternative evaluations. The only caveat to that is it requires boundary conditions to represent the system-wide model impacts. So when you receive the typical year submodels, that included the boundary conditions that represented the typical year conditions in the system-wide model. So there are some sheds in the system that are impacted by the interceptor. So without those boundary conditions, you may just have a free discharge, and that's not really representative of what would actually occur if you are seeing backups from the interceptor into your system. So we want to make sure you have that boundary condition in your model. So for the design storms, we'll have to provide the same thing. We ran the system-wide existing condition model for the 2-year design storms, and we'll be providing you the boundary conditions for those to just apply directly into the model you've already received from us, as well as the rainfall files.
So that's an additional.
Yes.
Correct.
You do have a question there from Tim. It says, please confirm the new model was calibrated.
The model was calibrated based on the 2008 data. The December 2020 model was mainly hydraulic changes, and we haven't, for the design storm model, we haven't changed anything to the existing conditions model.
Yeah, just to add on to that, the model was, as Amanda said, calibrated to the regional flow monitoring data and went through the calibration validation process, at that time. It hasn't gone through another round of recalibration. What it has been done is updated to reflect current conditions. So those are primarily hydraulic changes of either a change to a regulator, maybe that regulator's been closed, maybe a setting has been changed. There were some stream removal projects that were incorporated, and those were updated based on the greatest information that was available. So primarily the hydrology did not go through major changes. It was really the hydraulics. Now, for some of the stream separation, we knew that there was 20 acres that were bringing in the stream. Those 20 acres were removed from an input to the combined system and made a direct storm outlet for those. So that was the process that went through for the updated models in 2020.
So just to go over how the flows into the model were developed, dry weather flow is stored primarily and referenced in an external inflow file. That's the .dat file that you would have received. It's a continuous time series from for 2003. That's based on historic flow monitoring data. It includes the base wastewater flow and the groundwater infiltration. That's the bottom two curves in the chart below. The way the dry weather flow was distributed in the system, say you had a POC shed with 5 subsheds upstream of a flow meter. The base wastewater flow that was deconstructed from the flow monitoring data was distributed based on population. So if this smaller shed was 20% of the total population, 20% of the base wastewater flow from the flow monitoring data was applied to that shed. And that was done for the other 5 subsheds. Groundwater infiltration, it was distributed based on acreage. Because groundwater infiltration differed more between the 2008 data and the 2003 typical year that the model was calibrated or is used for, the validated groundwater infiltration was translated to the 2003 groundwater infiltration based on regional flow monitors.
You mean 2008 or?
The 2008 groundwater infiltration, that's the 2008 data had to be translated back to 2003.
So it's a typical year.
Yeah.
2000.
Yeah. For wet weather flows in combined areas, it's mainly the overland flow that's being represented. And that's done using the following parameters. We have acreage, sewage shed width, ground slopes, DCIA or the percent impervious. You have Manning's coefficient, which just represents the runoff surface roughness, depression storage, infiltration parameters, and for ALCA models, they use the green amp parameters. And in some cases, the long-term RTK was used just to represent the longer-term INI. For separate sanitary areas, those wet weather flows were generated using the RTK method to represent RDII. And the RTK method is just 3 unit hydrographs. You have the short term, that's the first triangle, medium term and long term response. R represents the fraction of runoff. T is the time to peak, the peak flow. K is a ratio of time to recession to time to peak, which is just the slope at the tail end of the response.
So in the combined areas we mentioned, sometimes they use the long-term RTK value. That would just be that.
That would just be the third triangle. Yeah.
And not all combined sewer areas have that.
Correct.
Correct, yeah. As far as the distribution goes, similarly, the RTK in separate sanitary areas, that RTK was applied uniformly to upstream tributary areas. So all 5 subsheds here would have the same RTK parameters based on that flow monitor downstream. And any adjustments made to overland flow characteristics, if you have a combined system, those are made uniformly in the tributary areas. So if you find that the percent impervious had to go up 20%, that 20% would be applied to all sheds upstream.
Yeah, man, just going a little more detail on the RTK. Why the same RTK values were applied to all 5 of those subcatchments. Keep in mind that the way that works, it takes the rainfall times the acreage times the RTK. So if one area is 50% of your area, that means it's going to get 50% of the flow for that distribution. So it does essentially distribute it based on acreage, but the actual modeling parameters, the RTK, are done consistently up through that system.
Yeah, that's a good point. So just to go into the components of the model, you have the SWIM 5 files. This would be included whether you receive the PC SWIM model package or EPA SWIM model package. You have the INP file, which is the input file, contains all the geometry, pretty much all the inputs to the model, all the different properties of hydrology and hydraulic properties, coordinates. You have the INI file, which is the initialization file. That just contains some settings. And if you have a completed simulation, SwimFi will create a .out file, which contains all the simulation results, and the .rpt, the report file, which is just a summary of the results. If you're using PC Swim will also create a .chi file and a .db file. These are just additional settings that PC Swim uses. These files will not change the results of your model. They're just additional settings. To run the AlkaSand models, you do need to use these external files. We have the climate file. This file contains temperature data, which dictates how the model responds to precipitation. Whether if the temperature falls below 32 degrees, it might treat the precipitation as snow, so you get the snow melt effect. If it's high, it'll just see it as rain. Then you have the rainfall file, the inflow file, which is the dry weather flow we discussed, and you have boundary conditions, which includes river boundary conditions, and for your submodel, that'll also include the time series representing the system-wide model.
Those are multiple files, correct?
Yes, these are multiple. I think they're .dat files. And you also have the hot start file. This file pretty much helps stabilize the model in the beginning. Without the hot start file, you're running dry pipes in the beginning, and that can tremendously slow down the simulation. So instead, we ran a 2-day dry weather period to get some flow in the system to help stabilize the model.
Which is important for a full year because there's
Yeah, there is a huge storm. Yeah, January 1st. So it's you would get different results if you start off with the dry model versus one with already your base flows in there.
This is one we've talked about in the past, that as you're making updates to your model, if you're making an update, you should recreate that hot start file to reflect your current model condition, so that it is starting with the correct, it's the exact same hydraulic system or hydraulics system as what you are trying to run.
Yeah, sometimes I think EPA Swim or PC Swim will throw out an error if you do have a change in your system. It will say that the hot start file wasn't compatible, and then you just have to create a new one.
we have guidance on it.
Yeah, there was
Yeah.
a previous presentation that provided an overview of how to create those.
Back to those files, Amanda, so that
Yep.
all the external files we provided for models, they're in a folder, right? It's called, it'll be the model name and then _files, right?
Yeah, it's in a subfolder of the package we received or we sent to the municipalities. So just to go over the 2-year rainfall design storm that whose files will be which we'll be sending out to you. 3 Rivers Wet Weather actually developed the summer and winter design rainfall distribution shown below. The 2-year summer design storm was about 2.33 inches, and a 2-year winter design storm was up about 1.64 inches in total. So in the chart below, I'm showing them on top of each other. When you run the model, the summer design storm will actually be run for a period in August, and the winter design storm will be applied to a period in January. Do I go over here?
Right, so with that, we are recommending that when you're looking at design storms, you really should look at both the winter and the summer condition. As you can see from those hyetographs, essentially the summer is going to be a lot more intense rainfall, so you can get a lot higher peak rates. One of the things, going back to those RTK parameters, what you'll typically find is in the winter, those parameters vary by season. Those have a much higher capture value in winter. So even though you're seeing a lower volume of rainfall and a lower intensity of rainfall, that could result in higher flow rates than what you're going to see in the summer because of that ability. And if you think about it, why there are higher capture in the winter is you don't have your grass, you don't have the trees, you don't have the vegetation to help uptake that water. So now it's raising that groundwater and leading to additional infiltration. You also don't have the same evaporation and things along those lines that help dry things up. So that's why it's important to look at both of those design rainfall conditions.
If you accidentally run the summer precip in the winter, you're going to be.
Yeah, we don't need to double that up. You'll get extremely high values from that.
So to run the 2-year design storm, you will receive the following files. You have the 2-year summer rainfall, the 2-year winter design storm rainfall file. And if you're running the winter design storm, you have to replace the climate file with a modified climate file. This is the same as the original climate file you received, except for the period where the winter design storm is applied in January. That temperature data was replaced with temperature data in March. This was done so that all the precipitation seen by the model will be treated as rainfall and not snow. So this is a little bit conservative. We want to make sure we capture all that rainfall as actual rainfall and not snow. And you also receive an updated non-river boundary condition time series. So that's, again, time series representing the system-wide model from where your model was extracted from. The inflow file and the river boundary condition time series files will not be changed. So you can leave those the same. So now we get into actually running a design storm, the fun part. This slide is just a general approach. I will be going through each of these steps in a little more detail, as well as giving a demonstration at the end in both PC Swim and EPA Swim. So the first thing you need to do is save the model as a new file. We recommend changing out the typical year, the TY, in your model file name to like SDS 2-year or SDS or WDS 2-year for the winter design storm or summer design storm. Then you'll go in and change out the typical year rainfall file with the 2-year design storm file. And you have to change out the boundary conditions from the typical year to the 2-year design storm boundary conditions. And again, if running a winter design storm file, you're going to have to change out the climate file to reference the modified climate file. And I have here listed the time periods that you would need to simulate for. If you're running the summer design storm, it has to be run for between August 16th and August 24th. For winter design storm, that should be run between January 18th and January 26th.
So Maddie, just let me add a little bit there. This has been a question that's been asked in the past: is when we run a design storm, do we run that inside the typical year simulation? Do we run that separate? So what's recommended is it's a separate simulation, but we aren't inserting that typical year into, or that design storm into a time period within the typical year. The reason we're doing that is we need those other files that have already been provided. So what's the base wastewater flow? What's the groundwater infiltration? So we need those parameters of what that'll be. And that's why these time periods were selected. These are time periods where that groundwater, the dry weather flow is basically stabilized. So it's not coming up due to previous rainfall. It's not still coming down from receding from a prior rainfall period. So it's kind of a stabilized time period within the typical year, but that way it gives us all those other parameters that we need to make those simulations. It also is a lot quicker to run just that week than running the full typical year. So it's also going to make it more efficient. Yes, Jake.
So I wasn't sure about these time periods and the fact that in the past we've run design storms for June, July, and August, or when the winter ends, January, February, March. So is this was a region-wide selected time period? Okay.
Yeah.
And as we said before, if changes are made to the model, a new hot start file should be created. And then you should be ready to run the simulation. So go into a little more detail. Again, I'll be doing demonstrations. I'll kind of go through these kind of quickly, but if you have questions, let me know. To update the rainfall file, that's done in the rain gauges table in both EPA Swim and PC Swim. You're referencing this external file. And with that, you also have to change out the station ID from the typical year rainfall pixel ID that's referenced to either SDS 2-year or WDS 2-year for the summer or winter design storm. This just shows a screenshot of what that looks like in PC Swim. The path for the design storm is just applied to the file name. You can just copy and paste directly into PC Swim. Same thing with the station ID. You bring in SDS 2-year or WDS 2-year, you copy that first cell and paste in the rest of the column. It's a little more cumbersome if you're using EPA Swim. We recommend going directly into the input file, copying out that rain gauge table into Excel, and then you can make the changes in Excel. Put the path name in that first cell. For EPA Swim I recommend adding quotes to the start and end of their path name. Sometimes if you have a space in your path, it's not going to get processed correctly by EPA Swim. Same thing for the station ID in column G. You just type in the SDS 2-year or WDS 2-year in the first cell, you copy it and you paste it into the rest of the column. Then you have to select the entire table, copy it out, and replace the old text in the rain gauge section of your INP file. And when you exit out of that, you open up the INP file in EPA Swim, and you should see the rainfall file brought in. I'll go through that. I'll demonstrate that to you after this presentation. The next thing you do after referencing the rainfall file is updating the boundary conditions. So for this, you open up the time series editor. You can do this directly in the time series editor. There aren't too many boundary condition files you'll have to be updating. I recommend changing out the typical year references to SDS or WDS 2-year, and then you're going to change out the external data being referenced and bring in it's going to be a similar file name. It will have a model element ID in front, underscore the storm, and then dash flow or head, indicating if it's a flow time series or a head level time series.
Just as your go ahead, Jake.
The reason to do it this way is that the references in the model will pick that up, by changing.
Yeah.
Adding it in, then you have to re-reference.
Yeah, that's a good point. So these time series are referenced by different elements in the model. So like the most downstream outfall you have, which may represent the interceptor. In this case, that might be the M61-GT element. Instead of going in and adding a new time series here and then having to reference it back into your at the element, changing it in this menu will automatically update the reference in the model.
And just as a reminder for the different boundary conditions, the flow and the head, typically that head is going to be something at the downstream end of your submodel, so you're representing a downstream boundary condition. The flow is typically going to be at the upstream or somewhere up in the system where something's been clipped off, and we're representing the flows that would normally be coming in at that point that have been clipped out of your particular submodel. So that way we're still accounting for all the upstream flows. We're also accounting for any kind of downstream head boundary condition that may be at the downstream end.
This is just repeating what I had talked about. We're changing out the typical year references to SDS 2-year or WDS 2-year. Changing the external data file to reference the updated data file. And that needs to be done to each non-river boundary condition time series. A table will be provided that will list each submodel elements where the time series had come from, as well as the model element that it should be applied to in case in case you need to re-reference it. It's sort of just a key table. Again, for winter design storms, you have to change the climate file to the modified climate file that will be provided. And this is done in the climatology editor under the temperature tab. To set up the simulation, we need to change the start and end date times, depending on your winter, if you're running the summer or winter design storm. And also in the simulation options, under the files tab, you have to remove the reference typical year rainfall. Otherwise, it's going to try to look for your the station ID, WDS2 year, or the SDS2 year in your rainfall file. So we're already referencing the rainfall file in the rain gauges table. Then you just need to remove the typical year rainfall file in the simulation options. Again, if changes were made to the model, a new hardware file will have to be created. Yep.
That just make it the model run longer?
No, I think it may throw up errors because it's looking for. We had changed out the typical year pixel ID that the rain gauges are referencing to SDS2 year or WDS2 year, and that name is referenced in the design storm file that we are providing. If we leave their typical year rainfall file in there, it's gonna. I think that external file in the simulation options supersedes the one referenced in the rain gauge table. So you have to remove that in order for it to read the design storm file. So now I'll do a demonstration in PC Swim first, and in the same model, I'll do one with using EPA Swim. Before I get into the demonstration, are there any other questions?
Get into this later, but talk about the dry weather flow being loaded as an external file. We talk about that.
Just that it includes a base wastewater flow and the groundwater infiltration. But we understand that as you're getting into the model and coming with alternatives, you may find that maybe that flow might have changed since then. So we're still having to think about how we're going to change that. We may have to work with Alcasan to provide those files to find some way to do that.
Yeah, I think the question, really is related to, obviously there is that external base wastewater or dry weather flow file. It contains both your base wastewater flow and your GWI. Obviously you're going to be looking to try to account for projects that the municipalities have implemented. Those projects may impact either one of those two parameters. If you redirected some flow from one area to a different watershed, obviously that's going to impact both of those components. Maybe it's a lining project and it's getting rid of that groundwater infiltration. Then we need to find a way that flow can be adjusted. It is kind of a complex issue. There's really, I see two issues that we need to take a look at. And Jake, I agree, we need to come up with a methodology and guidance, for this. One is physically, how would I want to go put a new time series in? So that's one aspect we need to evaluate. The other is, how do you come up with that parameter or what we think the new groundwater infiltration is? Because realize, as Matt had talked through the calibration and the validation of these models and how do we come up with the GWI that's currently in the model. That was really a two-step process. One was calibration to the actual monitoring data from 2008 or your non-synoptic data. But there was an additional step that looked at that and related that back to 2003 based on that regional flow monitoring data. So again, very similar to what we've talked about. How do I tell whether, trying to relate new flow monitoring data back to our 2008 to see how much flow reduction we have? We almost need to do a similar process to go back to 2003 for your typical year parameter. So that's the other aspect I think we need to think our way through and what's the best way to facilitate making those changes. So I do see that as an upcoming presentation or part of a presentation that we'll be providing some guidance of how to make those modifications.
A question online. It says when creating a hot start file using the old process for typical year model, we had to quote, change start analysis and start reporting dates to January 20th, 2003, and change end analysis date to January 22nd, 2003. Are different dates needed when creating one for the design storm model?
No, you can use the same period, January 20th to January 22nd. It's just a dry weather flow period. And that's what we want in the system. We would just want to start off with that base flow. So you can use the same period for design storm hot start files.
So no matter when you start your model, it's gonna run those 2 days. Or that day.
When you're referencing the hot start file, it just looks at the very end result of the 2-day simulation. So it's not rerunning that 2-day simulation. It's just looking at the end result of that January 22nd day.